Okay, hi, I'm Yogesh Khatri, and I'm going to be talking about Mac forensics today. Most people know me as a Windows forensics guy, and about 3 years ago, I decided to take the leap into Mac forensics and teach myself how the macOS works. And this is pretty much a culmination of that effort. I decided that the best way to learn Mac forensics would be to start from the ground up, and how about learn about all the artifacts and write code to parse them, not only parse them, but basically search, find, and parse them. And that's what led to this project being developed. So, but that was not the only inspiration. There were a lot of frustrations. There was a lot of needs and goals that I had for this project. When I started looking for tools, as all of us do, you don't want to write tools if they already exist. So when I searched for tools that already existed, I couldn't find any that were that would do what I wanted them to do. My goals were something that's free, open source, something that would work with a full disk image, something that I could just hit the button, it would go, it would mount the image, pull out the artifacts, and then present them in something like a spreadsheet-like format, which all of us like Excel, right? So setting out to do that, couldn't find any tools. Everything that was out there already assumed that you had a Mac image and it was already mounted up. And most tools that I saw that would go and pull out artifacts would simply open up all of theplists and SQLite database and then dump data back into a flat-out text file or something like that. They were either proprietary, not free, or depended on Objective-C, and they could only run on a Mac, or they required .NET, which meant they only worked on Windows. There were other problems. Up until, I want to say 6 months back, most tools, including commercial ones, actually all tools that I know of, did not support LZVN compression, which is something that Mac has had since El Capitan. LZVN compression, that includes, if you take account of the number of files, anywhere between 30 to 50% of your files were LZVN compressed. And that meant you were missing a big chunk of that data. In the last few months, most tools have caught up. But back then, I believe Blacklight was the only tool that could read a disk image and show you all your LZVN compressed files correctly. So with all this in mind, I said, well, if nothing exists, we'll create a tool that will go ahead and do what we wanted to do, which was work with full disk images. Other than that, there was also the sheer volume of files that really bothered me. On a Mac, any of the recent versions of Mac from 3 or 4 years ago, 3 or 4 versions back, the sheer volume of plists and SQLite database. Does anybody know how many plists exist on a Mac these days, on just a base install? Take a guess. 800? Anything else? 1,000 maybe? 2,000? 3,000? It's actually 20,000. Close to 20,000 only plist files. Several hundred SQLite databases. Several dozens of logs. I didn't want to go through and parse each one of this manually. I did some Mac forensics several years ago. It was a lot simpler then. But now, I didn't want to go through 20,000 plists manually. So that was another reason where I decided, well, you can't do this manually. You have to automate it. Let's go there. Another reason for automation is this thing called SFL files. Manual analysis can only go so far. How many of you have encountered SFL files and tried to read them? Raise of hands, please. Oh, a few people have. If you've been doing Mac forensics, you've probably come across SFL files. Again, these have been seen since El Capitan onwards. These are the ones that keep track of your recent items mostly. These files look something like this. They are not human-readable plists. They are meant to be machine-readable. This looks complicated at first. You can't make heads or tails of it just by looking at it. So is it impossible to read this by hand? No, you can read this. Let me show you how you can read this. SFL files, you start by going to the $objects, the $objects thing over there, and you number all of your objects in that tree. Once you number the objects, you start at object number 1, and then you start reading those values out. And from what you can see here, object number 1 is a NS dictionary. Well, you don't actually see that because I haven't quite expanded that $class variable there. But I can tell you it is of type dictionary. And dictionaries are just key value pair tables, if you may. So here you can see there are about, okay, let's try the laser pointer. That's the keys value, and right there is the values associated to the keys. There are 3 keys here, 2, 3, and 4, and the corresponding values are 5, 6, and 10, except these themselves are not the keys and values. These are the locations to the keys and values. So that would be the location of the first key. And that means the first key is located at object number 2, which is located down there. So the key itself is version. And the value corresponding to that key is in object number 5, which would be the value 1. So after this analysis, you then have your key value pair, version equal to 1. And this is an iterative process. You keep doing this throughout to read this file. Not efficient for humans. Machines can do it in a split second. So if you keep reading that, the next thing you will see in there is the next key value pair is 3 and 6. Key represented at 3, value at 6. And, oops, I don't think we can see that, but there's supposed to be a highlight around object number 6. 3 is version, and 6 is that thing over there. This is object number 6. It's another dictionary. So you have this dictionary embedded over here. You have a dictionary inside a dictionary. And very quickly it gets complicated as you have nesting and embedding involved. So again, difficult to interpret manually. But if I keep moving forward and confusing the hell out of everyone, which is not the point of this talk today, we'll just quickly move ahead. So here you have one more key value pair, which is 7 and 8. And those are the values. So com.apple.ls shared file list dot maximum amount, value equal to 10. This is the reconstructed plist. Instead of those 50 lines, once you read it manually, you can reconstruct this. Or better, write a program to reconstruct this human-readable plist from that SFL plist. So again, an example of where manual analysis really fails, and you have to write a program to do this. So for all of these reasons put together, I decided to create Macapt. So what exactly is Macapt? Before I talk about that, I'm talking about a little bit of the design, of what the design considerations were. As forensic analysts, as I mentioned, we love Excel. We like to see Excel-like output. The output of Macapt, once it's done processing the various artifacts, is going to be in CSV files, Excel, databases, and SQLite databases. As for input, this will work with E01 files, the gold standard, I suppose, for imaging. Not the gold standard, but the most used standard. It'll work with DD images. You can feed it individual artifacts too. So if you're working in forensics, you're likely to have a full disk image to process. If you're working IR, very likely you only have individual artifacts,plists and SQLite databases which you've already collected from a triage, or maybe you want to run Macapt on the actual system and get output. All of that is possible. So it works with full disk images, works with individual artifacts, also works with mounted images. If you have an image already mounted up, you can point it to the root of that image. It will go parse everything out for you. In the interest of time, we're going to move quickly here. It's completely open source. Every library we've used, we've made sure it's platform agnostic, and it works on Windows, Linux, and Mac. There is a native HFS parser, which I put in there, a native APFS parser. So this project has been out for about a year. That was version 0.1, but it's improved quite a bit since then, and now I think it's time I can talk about it. But as far as APFS parsing goes, we don't do encrypted images yet. Maybe something we can add in the future, but basic APFS support is there. In fact, I added APFS support back in December, and I believe we were one of the only DFIR tools to support APFS at the time, the first freeware tool to support APFS, full disk parsing. So, in a nutshell, what exactly is Macapt? It's the find all evidence button, as we used to say in my company, my previous former employer. But no, it's close to that. What Macapt is, this is the architecture. You feed it an evidence file, and under the hood, the framework goes ahead, parses it out, pulls out the various layers, the partitions, the file systems, determines which partition has macOS installed, goes ahead and mounts that, and then once it's done with this, through an API, it provides all of this information to individual plugins, and individual plugins can go and pull out the various artifacts. So really, this is a Python-based framework which is extendable. You write plugins to target different artifacts on the Mac. So we've got a plugin that will target all your Wi-Fi points. It'll bring that information out. We have a plugin that will get you all your recent items. We'll have a plugin that will get you information about Spotlight shortcuts. We have another plugin that will get you information on the Safari history files, for example. And there's a laundry list of these ones. Once the plugins are done processing, we have unified output, which is, I think, one of the really cool features we have. In a single API call, you can write out to a CSV file, an Excel file, as well as an SQLite database. And as analysts, I like to use the phrase trust but verify. So this allows you to do that. Any artifact that Macapt will process, it will automatically export out of your evidence and put it into an exports folder for you for manual review. So by analysts, for analysts. This is the help file. If you run Macapt -h, you get this long list. It looks complicated, but it's not. It's just showing you all the input-output options. And then at the bottom, you can see all the various plugins, and it's a very long list. So when you run it, it looks something like this. It takes about a few minutes to run on an average sized image. I have had this run from anywhere between 2 to 10 minutes, and it's done. Once it's done, the output looks like this. This is the Excel file output, and what you'll see here is there is a single tab, in some cases, well, a single sheet for each plugin output. So all those sheets down there, they are from each single plugin that was run. And right now, you are looking at the output of the Active Directory Domains plugin. This is telling me that this particular Mac was connected to the FOR 420 domain, and it's giving me information about that. Now, I'm not showing you all the columns, because the screen is only so much wide. But pay attention to that last column, which is the source column. Now, again, trust but verify. Every row of data, every single sheet in there is going to have that source column, which is very important from DFIR. It will tell you exactly where that data came from. So you can go and manually verify it. OK, in the next few slides, I am going to walk you through some of the outputs, some of the plugins that we have, some of the more useful information. Now, as an analyst or a forensic guy, if someone comes to me with a MacBook or a MacBook image and says, hey, process this, what are some of the most pertinent things immediately, right off the bat, regardless of what the case is, that I always want to know about the evidence? So first that comes to my mind is, OK, what's the operating system on it? What's the version of the OS? What's the time zone setting? What's the file system on it? How many files and folders are there? How much free space is there? Some basic information about the evidence. We have a basic info plugin that gets you all this information. On a Mac, if you go do the About This Mac dialog, it gives you some of that information. This is the output from Macapt, the basic info plugin, and it tries to get you most of that data. We can even pull the serial number from there in case you ever want to go back and verify that you imaged the right Mac. That happens. I've seen it happen with some of my colleagues in the past. Unfortunately, we've imaged the wrong machine. Okay, the next thing that I always want to know on every single case, how many users exist? Macapt will pull that information out. We have a users plugin that will give you a long list of users. Again, you are not seeing all rows and all columns here. I'm only showing you some of the users here. On any Mac, you have anywhere between 75 to 100 users, depending on the version of the Mac, because most of those users are the default ones. They're used by services. They usually start with an underscore. I've removed all of those. These are only the actual users with user accounts that you're seeing here. We can also get you the deleted user information. This comes from one of the plists. And if your user has auto login enabled, we can pull that user's password because it's really stored in an obfuscated format in the /etc/kc password file. We can go and unobfuscate it and then just give it to you. And then you can use this to do other cool stuff. You can take that password and then go decrypt his keychain and find more passwords. If you're using a Mac, very likely you're using the Safari browser. We can pull pretty much all the information that Safari leaves on the machine from the user's library/Safari folder, which includes search history, the downloaded files, last sessions, extensions, if any. The only thing that I haven't coded is the cookies. That's procrastination on my part. It's lowest on my list of things to do. But yes, cookies will be there too. On a Mac, unlike Windows, it saves every single print job. Anytime you print anything, that is saved. So we have a print jobs plugin in Macapt, and that will pull out all of your printed history from every single printer that you've connected to, which I think is pretty cool. It'll give you the name of the document that was printed, the time that it was printed, the number of copies, which application was used to print it, all that cool stuff. All of this is located under private var spool cups folder, and the files usually begin with C followed by a number, so you'll see C0001, C0002, and so on. We have a plugin that will get you terminal session history. This is one of my favorite new items. Macs have always saved your terminal history as well, not only Macs, all Unix, Linux saves your terminal history as a bash history file under your profile. But since El Capitan, Mac implemented saving history on a session-by-session basis. Which session am I talking about? A session here is just a terminal window. Anytime you launch a terminal window, that is defined as a session here. And the commands you enter in each different terminal windows are logged separately. They're not exactly in that format, but this is located under your profile under a folder called bash_sessions. And there's about a set of 3 files for each session. And the way it works is it will show you commands that you typed in that session, as well as all prior history. And then the next terminal window you launch, it will show you all prior history, and then followed by commands in that particular session. So if you were to actually compare those files and remove the common element in there, and then you compare the timestamps on the files, you can actually come up with this short list of, OK, these were the commands that were actually run within this particular session. If you want to read more about that, about a couple of months ago, I wrote a blog article on that. Please go ahead and do that. I'm just going to move forward in the interest of time. But it's very interesting. This is great information for DFIR folks, because now, prior to this, you could not tell when a single command was run. Was it run yesterday? Was it run a year back? I don't know. Now, you can tell exactly, because there's a time frame associated with each set of commands. So this is great. We have a plugin called Recent Items. The Recent Items plugin gets you a lot of information, including recent, not recent, but actually all volumes. Anytime you mount a volume, an external USB disk, an internal disk, a DMG file, all volumes that you mount are actually logged in OS X. The recent items plugin pulls all volume information. It will also pull all recently used items. These, by the way, are all coming from SFL files, and it's limited to the last 10 recent applications per user. We can get you your recently used applications. We can get you recently connected to servers and hosts. If you use Finder to connect to other machines, and here you can see me connecting to my phone because I have a Droid NAS device app, and then I transfer files that way. You can see me connecting to my SD card right there. I also, this plugin also gets you the recently accessed documents and folders. Anytime you access any folder or file in Finder, that is logged too. So this is a plugin that does a lot of heavy-duty lifting in the back end. It reads hundreds ofplists and SFL files to get you this information. This is a plugin that one of my students wrote. He's actually here, Jack Farley. If you use iMessage, we can parse all of your chats now. And it's pretty cool. All of your chat record history just laid out right there, including any attachments if you have, if you've sent attachments. If you notice just below that smiley, you can barely see it, but it says OBJ in a little, with square brackets, with OBJ with a dotted square around it, right? That is the symbol for a Unicode object placeholder. We haven't inserted that. That's just the way it is in the database. That means that an attachment was sent over, and that's a placeholder for that. There are columns to the right of this, which we are not showing here, which detail all the attachments that were sent through attachment metadata and where they are right now. Anytime you've typed in shortcuts, you've typed in a search term to search for a document or an application, this is the primary way you would search for documents or applications and launch them on a Mac. Here you can see that I just type in TE, and I hit enter, and that launches the TeamViewer application. Macapt will pull all of this out from the com.spotlight shortcuts plist in my profile. Again, sometimes this is very useful information in an IR investigation. If you've used Wi-Fi, which everybody does, Mac keeps a track of all of that. Macapt will pull out all of your Wi-Fi history, and here you can actually see me in Austin in 2015. This is from my old MacBook, and at Zurich Airport in 2014, and Oakhurst, California, again in 2015. This is one of my favorites. Notes and notifications give you, at times, very useful data in your investigations. And I think these are artifacts that are often overlooked by investigators, and they're not frequently talked about. So I've blogged about the format of the Notes database also earlier. The Notes app ships with macOS by default, and most people use this to capture all kinds of miscellaneous notes. This is Macapt's output, and often you will find some very interesting data. A lot of times users will put passwords and other really good stuff that you can use in your investigation. We can parse all the Notes databases, most of them. There's about 6 or 7 different versions of this, and it took some time to accommodate all the variations. And this is the second favorite of mine, alerts and notifications. So what you see on top is an alert, and as soon as you hit close, that goes away. Sometimes, depending on which API was used, the alert may go away, but it may come down into the notifications pane and stay there. This is the output from Macapt, which gives you all of that. As you can see, Mac OS only shows me the alerts from today and maybe yesterday, the last few days, but it will not show me anything older. In this case, I had not used this machine for many, many days, and so there was nothing for yesterday or the day before. So it's only showing me 3 alerts from today, but if you parse the database, you're going to see a lot of information, good information, including snippets of emails, messages from different applications. I think about a month ago, Patrick Wardle from Objective-C made the discovery that the Signal Messenger, which is supposed to be a secure messaging app, which delivers a message to you as soon as you read the message, it's supposed to auto-delete that message. Because they used the wrong notification API call, it actually ended up being embedded in the notifications database. And if you were to go and parse that, you would get all of the Signal store delivered messages. So again, can be pretty useful in an investigation. In the interest of time, I'm going to just skip over this. Whenever you download something from the internet, typically Mac will scan it. There's technologies under the hood like Gatekeeper that will scan all of these downloaded files and make sure there's no viruses or malware in them. There is a database which is called the Quarantine V2. Macapt goes and parses that database for you. Again, pretty good, useful resource if you have a compromised machine and you want to see what was downloaded and opened up. The user may not remember. Regardless of whether you click open or cancel on that, it's going to make an entry in the quarantine database anyway. This does not work if you are doing private browsing. Incognito, it will not go to the quarantine database. But for everything that was downloaded normally, it will. And this is something that is new and upcoming. And I want to talk about this because I'm really excited. When I talk to Mac experts, a lot of them simply give me this phrase. They say to process a Mac, you need a Mac. You can't process a Mac without a Mac. And I sort of take it upon myself to break that stereotype and say, no, I want to be able to process a Mac on a Linux box. Why not? Through a completely open source solution. Why not? And part of the reason why they say that, and they have good reasoning to say that, it boils down to mostly one artifact. And that one artifact is the Spotlight database. The Spotlight database is a mostly unexplored entity which nobody knows the format of. It's undocumented. So we took a look at it. I was able to decipher the format, and I now have a plugin which should be out in another couple of weeks, which will get you all of the Spotlight data. So what is Spotlight? Spotlight is the service that indexes all of your data and metadata for every single file. So inside Spotlight database, it's got information for all of your Office documents. It's got email metadata. It's got ID3 tags. It's got information from your TV shows. Any and every file that you have, metadata has been recorded, which in and of itself is not that great, because you have the full disk image. You can get that data from the files again. But there's at least 4 to 5 different types of data which Spotlight collects, which is nowhere else on the disk. And one of the data you can see in this screenshot, this is a Finder window, and I've clicked on the Recent button. This is showing me all the recently opened files. How does Finder know the recently opened files? That timestamp, date last opened, is only stored in Spotlight. It's not in the file system. It's not anywhere else on the disk. Other than date last opened, there is also a number of times you opened a particular application or document that is stored in the Spotlight database. There's also a field that stores where if you downloaded a file, where did it come from? The entire URL of where it was downloaded from. So there's at least 4 to 5 different pieces of information that you don't have anywhere else, which is only in Spotlight. And this is the output of Macapt, the SQLite database, and I'm running a query over the output of Macapt to recreate pretty much the same view. And as you can see, it is the same dates and times and the same exact files. So this module will be out in the next week or so, because I still need to do some more debugging and testing on it, but it's mostly done. So I'm really excited about being able to parse Spotlight data. And this is it. This is the full list of plugins that Macapt parses out. So we haven't talked about every single one. There's a networking plugin, which gives you all of your DHCP information and the last IP address and all of that. There's some other stuff in there. There is net usage, which again is really cool. It gives you the usage information, pretty much what SRUM does for Windows. Net usage is a sort of a subset of that. It'll tell you which application used or consumed how much data up and down over which interface. It's pretty cool. And in the near future, this is what's planned out for Macapt. So I want to upgrade the code to Python version 3, because right now it's a Python 2 only program. And one of the other artifacts that right now you need a Mac to process is the Apple Unified logs, which none of the tools can process because we don't know the format of Apple Unified logs. It's no longer a text file. So it is on my list of things to do to reverse engineer Apple Unified logs too. And then some of these other items, at least 3 or 4 of these are currently being worked on either by myself or one of my students. And these will be out shortly. And that's about it. Thank you.